classifying sedimentary rocks. Now recall that a sedimentary rock is either made by pieces of broken down rock or by dissolved pieces of rock. So clastic clearly is made by rock pieces, and within the clastic category we're going to look at how big are those pieces. The size of the piece is then how we are going to classify it. Now one size is Boulder, which I don't have a slide for in this presentation, but that's going to be very large, and as the name implies, a large broken off piece of a rock would be a boulder. Gravel sized, as you can see in the image, we're looking at pieces a few millimeters to centimeters across. And the picture here is an example of quartz pebble conglomerate. Breccia also counts as a clastic gravel-sized piece. Sand size, you're looking at no more than 1 millimeter across. This is going to feel grainy. Oops, to ease and feel. And you can see the grain. So sand, of course, turns into sandstone, and this is a picture of one type of sandstone. Arkose also would have sand-sized clastic pieces. Silt and clay, this is going to be very, very small pieces that you can't see. But you can feel. So when classifying clastic rocks, you're looking both at the appearance and at the texture. So siltstone, claystone, that kind of makes sense since we've got silt and clay-sized pieces. Shale also qualifies as a silt and clay-sized clastic rock. So non-clastic, this is going to be related to the dissolved material rather than the broken pieces. And there are different formation processes. Precipitation is when there are pieces large enough that they just float down through the water. So as an example, if you are a sweet tea fan, like I am, then you know that if you get non-sweet tea and you just add sugar to iced non-sweet tea, you can stir it up and you can get the sugar evenly distributed, but if you let it sit, the sugar eventually floats down to the bottom of the glass. That's precipitation. It was mixed in with the water, but it will eventually float downward through the water. That's precipitation. Crystallization is when the water evaporates and the material that's left crystallizes. So if you had salt water, then if you evaporate the salt water, you will have little salt crystals remaining behind. So that would be crystallization. You can also have biological formation. Remember that our mineral definition, it had to be inorganic, no plants or animals involved. In the case of sedimentary rocks, we can have plants and animals involved. Fossils count as sedimentary rocks. As the material breaks down from the plant or animal, that cements material together, and so that would be a non-clastic biological rock. And then non-clastic types, one type are called carbonates, and that's because there is carbon dioxide as somewhere in the rock. It's part of the composition of the rock. For these, if you apply a little acid, they will bubble and dissolve. And what they release in the bubbles is the carbon dioxide. Limestone is a key example of that. Dolomite, coquina, chert, all of those have some carbon dioxide in them. So that is a carbonate sedimentary rock, non-clastic. Evaporites, as the name implies, these form by evaporating water. And you notice the two listed here, gypsum and halite, we also had in our list as minerals. But now we have dissolved the minerals and then evaporated the water. And so the reason why these are no longer minerals is they are no longer crystalline. Remember, a mineral has to be in that crystalline structure. These have lost that crystalline structure through this process of dissolving and then resolidifying through the evaporation process. Coal is kind of in a category all itself. Of course, this is related to organic material. It's broken down plant and animal material that has gone through a lot of heat and pressure. And so when it first forms, you've got peat. That's not a terribly effective source of energy, but it works. If you apply a little heat and pressure, you get lignite. More heat and pressure, you get bituminous coal. And anthracite is the most affected by heat and pressure, and most changed of all of these, and also the most energy efficient. So coal is non-clastic because it is made out of organic material, not pieces of rock. But we could also almost categorize it as metamorphic, which we haven't defined yet, but this fact that it does change due to heat and pressure is also kind of like metamorphic rocks. So it's kind of on its own category there. But these are the different kinds of sedimentary rocks that you will encounter.